So the next question, these are still paper 4 questions, so still calculator paper questions. When you have to describe a single transformation that's the same thing as doing one of these, you basically just need to do what it says and then work out how to get from what you started with to what you ended up with in one go. So a translation of -7, 2 means that you would go left 7 up 2. So if we count 1, 2, 3, 4, 5, 6, 7, up 2, that would take me up to there. And then it's followed by a translation of 3 minus 5. So that means now I'm going to move this point 3 to the right. 1, 2, 3. Down 5. 1, 2, 3, 4, 5. So my triangle would end up here. So I've got to say, how do I get from here to here in one go? Well, it's still just being picked up and moved. So it's still a translation. So that's one mark. And then your final mark is going to be the vector here. So to get from the same point on that triangle to the same one on that one, it's gone 1, 2, 3, 4 left. So that's -4 at the top. And then it's gone down 1, 2, 3. So down -3. So down 3. So -3. Right, the next question. So again, let's just do what it says and then work out how to get there in one go. So it says a reflection in the line y equals x. So y equals x is where it goes through 0, 0, 1, 1, 2, 2, 3, 3. So I don't actually have a ruler, but we will join those up. So reflecting that triangle then in that line. So that one is on the line, so that's going to stay the same. This one is 1 square across, so I'm going to go 1 square up. And then this one is 1, 2, 3 across, so I'm going to go 3 up, so 1, 2, 3. So it would go up to there, like that. And then the final one is rotation of 90 degrees clockwise around 0, 0. So I'm going to trace over this triangle here. I'm going to hold it down on 0, 0, 90 degrees clockwise. So that is when the top of the paper goes to the right-hand side. I was going to try that one more time because I am moving everything around, so draw it a little more accurately. That's the one I'm looking for. 90 degrees clockwise. It's really hard not to move this piece of paper. Here we go. Right, so it's going to go here. Like that. So now you've got to say, how do you get from here to here in one go? Well, that is a reflection. So that would be 1 mark. And then you've got to find your line of reflection. So halfway between them would be along here. And that is just the x-axis. So it's reflection in the x-axis like that. Right, the next question is a percentage one. So we know that Amy receives a 20% salary increase and her new salary is 18,000. So that's including the 20% increase. Now what you can't do is find 20% of this and take it off, because 20% of this new amount is going to be different to 20% of what she started on originally. So that is the biggest mistake people make. So the new salary is including the 20% increase. So therefore this new salary is actually 120%. So what we're trying to work out is what the original 100% must have been. So to do that, we're going to work out what 1% is. Well, if this is 120%, I'm going to divide it by 120 to work out what 1% is. Just going to find my calculator. So 18,000 divided by 120. So that is 150. And I actually want the original 100%, so I'm going to times that by 100. So it should be £15,000. So obviously, if you've got a bit of time in the exam, you could find 20% of that, add it on, and check that you do get then 18,000. But like I say, what you cannot do is work out 20% of that, because 20% of 18,000 would be different to 20% of the 15,000 that she would have started with. Right, the next question is this one here. So it's a speed, distance, time question. I've got a distance, I've got a speed, and we're trying to work out the time. So first thing I'm going to do is just make a note of the triangle ready for when I'm sure I'm going to need it in a minute. So we're trying to work out how long did Aaron run for, so therefore that is the time. So I've got to do the distance divided by the speed. Now it's a 4-mark question, so I would always be careful of that because it suggests that there's a lot more involved to it than perhaps what we first think. And when you look at the units here, this one is meters per second. This one is kilometers. So that's going to be a mark straight away for changing this one into meters so it matches the units here in the speed. So you need to know how many meters in a kilometer. Well, the K usually stands for 1,000. So therefore this would be 5,000 meters. So now the units match up. They are okay to put into this triangle. So the time is going to be 5,000 because that's the distance divided by the speed, which is 2.2. So bearing in mind this is per second, so when we've done this division, that is going to give us the time in seconds. So that is 2272. Now we've got to give our answer in minutes and seconds to the nearest second. So if I've got 2272.727273, this is going to round it up to 2273 seconds. So that's probably 3 marks there. The final mark is now saying how many minutes this would be and how many seconds. So there's 60 seconds in a minute. So if I divide 2273 by 60, that will tell me how many times it goes into it exactly. So it will go in 37 times with something left over. So it would be 37 minutes. So I've divided it by 60 just so that I'm showing my workings. It'll be 37 minutes and then I've got something left over. So rather than trying to deal with that decimal, I would say 37 lots of 60 is 2220. So 37 times 60 is 2220. So if I do, to basically work out the remainder of what's left, if I do 2273 minus 2220, then I get 53 seconds of that. The next one is still to do with speed, distance, time. You can see we've still got a distance, it's talking about time, and it's given, I'm trying to work out a speed. So it's still going to be to do with speed, distance, time. But look at the marks, 6 marks. So there's going to be quite a lot again to this question that perhaps we haven't yet noticed, which is the fact the distance is correct to the nearest kilometre. That tells you that this is to do with upper or lower bounds. So straight away to pick up marks, let's try and write down upper and lower bounds where we can. So 53 kilometres, and that's to the nearest kilometre. So my lower bound would be 52.5. My upper bound is 53.5. So even if you don't actually need both of those, I would write them down in case you choose the wrong one later and you haven't written them both down and that's all your marks gone. So just write them both down even if you don't need them both. Then we've got 2.7 hours, that's correct to 1 decimal place. So with 2.7, remember with decimals, you just make the digit 1 less and put a 5 on the end. So 2.65 is my lower bound. Upper bound is 2.75. Even if you don't need them both, just write them both down. So we've got to now calculate the lower and upper bounds of her average speed. So speed is distance divided by time. I need to work out both the lower bound and the upper bound. So this is another reason why it's coming up as 6 marks, because of the fact that you've got 2 bounds. Normally they just pick 1. So if I start with the lower bound of this, it's a division. So you've got to think, do you want to start with a big number or a small number? If I'm trying to make it as small as possible, I need to start with the lower bound for division. But I would have to divide that by a bigger number because that's going to make the answer smaller. So for the lower bound, I need to do the lower bound of the distance. So this is why it's handy now. I've got them all written down. Lower bound of the distance is 52.5 divided by the upper bound of the time, which is 2.75. Answer's correct to 2 decimal places, so there's going to be marks for that as well. If we get that wrong, you will lose a mark. So this one is 19.09, so that is 19.1. Oh, 2 decimal places, that's my mark gone. 19.09. And then the upper bound is going to be the upper bound of the distance, and this time I'd want to divide it by a smaller number, so I'm going to divide it by the lower bound. So it's going to be 53.5 divided by the lower bound, 2.65. So that gives me an answer. Now it's 2 decimal places, remember, so 20.1, and the 8 would make the other 8 round up to a 9, so 20.19. Final question is to do with density. So straight away I would draw out my density triangle. So remember the McDonald's M goes at the top, and then the other two doesn't matter where they go. We've got to work out the mass. So I'm going to cover up the M. So at some point I'm going to have to do the density times the volume. Now we've got the density here. We haven't got the volume. 4 marks, so probably quite a bit to do. And you can see this one is in kilograms per meter cubed. These ones here are all in millimeters. So first of all, if I change these into centimeters, it would be, there's 10 millimeters in a centimetre, so that would be 40 centimeters. 40 centimeters. That, if I divide it by 10, would be 2.8 centimeters. But I want them in meters. So there's 100 centimeters in a meter. So I'm now going to divide these by 100. So this one would be 0.4 meters. Again, 0.4 meters. And this one, if I divide it by 100, would be 0.028 meters. It's a cuboid, so to work out the volume of a cuboid, I just need to times those all together. So 0.4 times 0.4 times 0.028. And we should be writing down what we're doing, so I'm just going to write down volume 0.4 times 0.4 times 0.028. So that equals 4.48 times 10 to the minus 3, or if you want that as an actual number, if you move the point back 3, 1, 2, 3, so it'd be 0.00448. So I need to work out the mass, so I'm going to times that by the density. So to be honest, you could have just left that on your calculator and timesed it by the 2250. Oops. So that is 10.08. That would be the mass of one of the slabs. So the final mark is going to be, actually we need to times this by 60. And so then you should get 604.8.